Okay, today we are doing lesson 1.2, sets of real numbers. Please make sure that you have your name and date already put on your notes. I have the essential question already there. How can you describe relationships between sets of real numbers? When you entered the classroom today, there was a PowerPoint that wanted you to do two problems on or in your notes. At this point, I want to go through those two questions with you. The first one stated, which statement about rational numbers is true? Statement A was that rational numbers can't be written as a ratio. That one is false because that is exactly what rational means. Rational as a ratio. Statement B, rational numbers are numbers that can be written as ratios of two integers where 0 is the denominator, is also false because we cannot divide by 0. Statement C, rational numbers are numbers that can be written as the ratio of two integers where 0 is not the denominator. A ratio can be expressed as a fraction. That is true because that comes directly from our definition of rational numbers. And just to prove D false, rational numbers can't be expressed as a fraction. That is the opposite of the definition. That was number 1. I forgot to put the number up there. Sorry. Number 2. Sammy worked late, so he decided to go out to eat at his favorite restaurant. His meal cost $22.56. The tax on the bill was 8.25%. Sammy left the waiter a 12% tip that included tax. Which expression below can be used to represent the tip Sammy left? His meal cost $22.56. The tax was 8.25%, and he left a 12% tip that included the tax. You have to recreate what you need to do. The tip included the tax. So you're going to the meal plus you have to add the tax on the meal and then a 12% tip. So that is answer choice A. So let's talk about our notes today. Real numbers is a word that we need to define. That is the set of numbers consisting of the set of rational numbers and the set of irrational numbers. Forgive my arm. Now let's talk about the set of rational numbers. This is the set that consists of whole numbers, integers, and fractions. I'm going to turn the page at this point because I need more room than what I have here to draw a diagram for you. Okay, here is my diagram. This diagram is also in your book. We are talking about the set of real numbers. What are real numbers? How can we show what real numbers are? Well, this section over here is our irrationals. Okay? That would be like the square root of 17, or the negative of the square root of 11, square root of 2, or the number pi. On this side, we have the rational numbers. Now, inside the rational numbers, we have the integers, and inside the integers we have the whole numbers. Whole numbers involve numbers like 2, or the square root of 9, or 0. Integers would add in -1, the opposite of the square root of 16. (24/6). Rationals would include something like 27/4, 4.5, -6/7, 0.5 with a repeating bar, and those are just examples. Some questions will ask you to say, what sets of numbers does this number fall into? So let's do a couple of examples. Square root of 5, well, that is, of course, a real number. And it is irrational, because it is not a perfect square. we have negative 17.84. Of course, that is a real number again. This one is a rational number because we could write it as a fraction. We could also do the square root of 81 over 9. Square root of 81 happens to be 9 over 9, which means we have 1. Well, of course, this is a real number. It is a rational number. It can be written as a fraction. It is an integer because it is also a whole number. And that's how you classify numbers according to what set they fall into. You are going to have problems in this lesson that ask you about sets and subsets. And again, I don't have enough room, so I'm going to go ahead and turn my page. This is sets and subsets. For instance, we could have the question, all irrational numbers are real numbers. And we would have to figure out, is this a true statement or a false statement? And this is true. You can look back at that diagram and find that irrational numbers are actually part of the real numbers. Another statement might be, no rational numbers are whole numbers. And you have to think about that statement a little bit. It's saying that there are no rational numbers that are whole numbers. But if you look at the diagram, whole numbers exist inside the set of rational numbers, so this one we would say is false. They could put this in terms of real world, with a statement such as, the number of people wearing glasses in a room. And they're going to ask you, what kind of numbers could we use for that? Well, can you have half a person wearing glasses in a room? I don't think so. So we're not going to have any fractional numbers here. So we're going to be looking at whole numbers. I would not say integers because we can't have a negative number of people. Another statement might be, the amount of water in a glass as it evaporates. Again, think about what numbers you would use for this. Of course, it's going to be a real number because there is a real amount of water in the glass. But is it going to be all real numbers? Will we have a negative amount of water in the glass? And I don't think we will. So I would say that this is real numbers that are greater than 0. Or I would say all positive real numbers. That would be another way to put this. At this point, I am now going to give you your assignment. One, of course, I'm going to remind you to summarize your notes. I'm also going to ask that you go ahead and set up 3 to 4 more pages in the Cornell format. That way we are prepared and we don't have to use that time in class tomorrow. And 3, in your book, you're going to be working on pages 18 through 20, and I'm going to ask you to do 1 through 29.